So welcome everyone to today's seminar. Today we have three astronomers that are going to tell us about the Vera Rubin Observatory Education and Public Outreach Program. I'll start by introducing Fernanda Urrutia, who currently works at LSST in Chile. She got her PhD at the University of São Paulo here in Brazil with a joint fellowship at ESO in Germany. And then she moved to Gemini in La Serena, and she's now been there for a few years. So Fernanda, I'll pass it on to you for you to introduce Ardis and Clare.
Hey, thank you, Ana. Hi, everyone. As Ana said, I am Fernando Urrutia. I did my PhD and my master in Sao Paulo, in IAE. Now I am working in the education and engagement group in Vera Rubin Observatory. So today we will talk about a little bit about what we are doing in the education team. And for that, I asked for my colleague, who is Ardis, and Clare, who are the expert and spend more time than me in this group, working on that. Ardis is a professor, was a teacher in the beginning, it is lead the part of the education things, all the activity with the teachers, and it is in United States. Clare is astronomer. They got the PhD 2 years ago, 3 years ago, something like that, Clare? No, I don't remember the university very well. You will introduce you 3 years ago. So, and she's working also in the education team, the EPO team. She's more focused in all the astronomy things, and she will talk about the citizen science, that what we want, one of the main goals of our group for the next year. So this is our group. You will continue with the first one, Ardis?
Yes, thanks. Hello, everybody. So I'm going to do the very first part of the slides, and that's going to introduce our EPO team to you, Education and Public Outreach. And I'll be talking a little bit about the education program, and Fernanda and Claire will be doing some other parts. So we can go to the first slide, Fernanda. Thank you. So our observatory is the first United States observatory that actually put a lot of money funding into the education and public outreach program at the very beginning of the observatory construction plan. And so this is pretty different, unique among many US programs and observatories. And we are very, very committed to our education and public outreach program for the entire first 10 years of our operations and hopefully beyond. Let me go to the next one. Thank you. A little bit about Rubin Observatory, if you're not familiar with it. It's in Cerro Patron in Chile. You can see here it's about 2,700 meters up at 30 degrees latitude. And right now we are just finishing up our construction phase. We're at the point now where we're just beginning to install our commissioning camera and going into some commissioning. We hope that our first light will be coming in late April or early May next year. That at least that's our tentative plan. Okay. Rubin Observatory is a survey telescope, and we'll be talking a little bit more about that in a moment. So it's a little different than a lot of other telescopes where there's Q observing or time allotted on the telescopes. And being a survey telescope, it is actually serving a number of different kinds of science goals. It was optimized in the beginning. We thought about it being optimized for dark matter and dark energy, and we'll talk a little bit about why. But it's also going to be discovering a lot of small solar system objects, and it's going to be an amazing instrument to catch all of the transient events, the things that are changing in the sky every night, as well as doing a lot of work in the Milky Way structure, formations, local environment, and stars. So those are our four main science goals. Go ahead, you can go to the next one. We have the largest camera ever designed for astrophysics. You can see that our images are almost 10 square degrees each. We have 6 camera filters that go from infrared to ultraviolet. And one of the really amazing things is our telescope is going to be taking images when it's operating about every 30 seconds all night long. So it's going to end up being about 2,000 images per night. And we will detect about 10 million changes in these images each night. Our plan right now is to image the entire sky from our location every 3 to 4 nights and do that consistently for 10 years. So because of that, over time, we're going to be building up deeper and deeper images as we co-add all of those images together. Okay. So Fernanda's going to play a little video about, this is a good example of one of our animated video series we have available for our EPO program, and it'll introduce the concept of a survey telescope.
Fernanda, should we hear sound?
There should be audio, but I'm not hearing it.
We're not hearing the audio.
Oh.
I think there's a checkbox you have to check on your audio settings.
Yes, I did.
There are many
No, it's
There you go.
Okay.
observatories around the world, so why build another one? What makes Rubin Observatory different? The telescope inside the observatory combines technologies in a unique way that opens up a whole new view of the universe. We know that space isn't boring. There's a ton of stuff happening all the time, but many exciting events are actually pretty easy to miss. Sometimes they're really far away or don't give off much light, and sometimes we're just not looking in the right place at the right time. But that all changes with Rubin Observatory. Rubin Observatory's 3 mirrors collect light from a big area of the sky at one time. The telescope can move around the sky really fast, and it has a super sensitive camera, the largest ever built for astronomy. Working together, these features make Rubin Observatory great at detecting faint or faraway objects and catching temporary events like supernovae explosions or small objects that move across the sky, like asteroids. It's the first observatory designed to do all these things at the same time on this scale. Rubin Observatory is what astronomers call a survey telescope, which means it takes images of the whole sky, not targeting any object in particular. The images Rubin produces are packed with information. They're like treasure chests for astronomers. Imagine all the discoveries we can make now that Rubin is providing our best view yet of the universe in action. Want to know more about Rubin Observatory? Find all our videos and much more on our website and follow us on social media.
Okay, Ardis.
Okay, can you get to the next slide?
There are many
Sorry.
All right. So you just heard about our survey, and if you just look here statistically at our predictions, you can see there is going to be a whole lot of data for a whole lot of different science projects. And so this is one reason why so many people around the world are extremely excited about our observatory coming online. And this data will be available for everybody who has data rights, and this will be many, many countries of the world initially. After 2 years, everybody has access to the data. Okay. Our telescope is named after Vera Rubin. She was an American astronomer. And originally, a connection is that the first name of our telescope was called the Dark Matter Telescope. And Rubin did a lot of her research on dark matter. And we're going to play another short video now to introduce Vera Rubin to those of you who may not know of her.
Why is our observatory named in honor of Vera Rubin? Dr. Vera C. Rubin was an accomplished American astronomer who provided convincing evidence for the existence of dark matter. How did she do it? Using a new technology, Vera worked tirelessly to observe and record the behavior of galaxies. Her data showed that some unseen matter must be out there affecting how fast galaxies rotate, and that this dark matter makes up most of the matter in the universe. Vera Rubin's work had a huge impact on astronomy, and it inspired the design of Rubin Observatory, which is carrying on Vera's legacy by helping us learn more about dark matter. But Vera Rubin's path towards transformational science wasn't easy. Many people discouraged her from doing science, saying that being an astronomer was not a woman's job. Vera did her research at a time when few women could even access telescopes, and observatory buildings didn't even have women's restrooms. But Vera believed that anybody who loved the stars should be able to study them. Vera Rubin once said, "We all need permission to do science, but for reasons that are deeply ingrained in history, this permission is more often given to men than women." When Vera saw examples of this inequality, she wrote letters asking editors, professional societies, and influential scientists to provide more opportunities for women. She also supported astronomers who were just beginning their careers. She invited graduate students to collaborate with her and insisted that their names be listed as co-authors on publications. She attended their talks, included them in social gatherings, and asked questions about their research. Vera Rubin once wrote, "It's all right to be charming, gracious, brilliant, and to be concerned for others as we make our way in the world of science." We at Rubin Observatory want to carry on this legacy of helping everyone join in the fun of discovery, regardless of their age, gender, or nationality. We welcome you on this journey, just as Vera herself would.
Okay, thank you, Fernanda. Our education and public outreach team has a mission statement that you can see here. And one of the things I want to emphasize about our mission is that just as Dr. Rubin was very, very concerned that everyone should be able to do science, we want our entire team approach, whether it's our website, our citizen science projects, our education programs, to be very accessible and approachable for all people, not just for scientists. Okay. Our approach here, you can see kind of broken out into 4 different bullets, is that in addition to being accessible and approachable, we want to reach a large audience. We want to be inclusive. And also we want to be interesting and engaging, in something you might notice as you look at our website and explore the different options, is that we have a tone that's a little bit less formal than some of the other science websites out there, because we want everybody to feel like they can explore our website and not be too intimidated or turned off by a highly technical nature. So we can move on to the next. Our group, we have about 10 people on our team approximately. And so we're structured in the way that we have kind of a content team that deals with things like the social media, the website, and other kinds of communications. Our formal ed team is specifically for the teachers in classrooms and supporting them. Claire's going to be talking to you about citizen science and how we're going to support the Rubin science community to develop our citizen science projects. And then finally, we have a technical team which provides all of the support we need to communicate all of this information through our website and our pipelines and our data center. One thing I will say about our team is we're very interdisciplinary. Many of us work on a number of these different teams. And so, you know, we kind of cross-pollinate each other, if you will, in order to get our projects done. So next, we're going to talk a little bit about what we're up to and breaking it down into the different categories. And the next slide is going to be about the Chilean and Latin American audiences. And I'll turn it back to Fernanda to speak about that.
Yes, I will talk about a little bit about what we are working here in, at least in Chile in or South America. I am start in the group, the EPO group, just this June. So I am starting with all activity. Despite I start with the education things from a years ago. What we are working here, we are working more with the teacher. So we are working a lot of doing workshop for teacher, just to present what we are, what is the telescope, the motivation of have a new telescope here, and share with them what we are doing, that EPO team. Focus in the education part, what we are working on that. Ardis will tell you about more about what we are doing in education things. So we are focused in workshop, face-to-face and online workshop. All of site are in Spanish and in English. We focus, the main audience are in Chile and in the United States. So all that we have is in Spanish and in English. And we are doing a workshop online and face-to-face. The next one online is in this Friday. And we also have several teachers from Brazil. So despite we are not speaking Portuguese in this time, we will have a lot of teachers that maybe can understand the Spanish. It's similar to the Portuguese. In any case, if you want to do some teaching workshop in Brazil, I can do. My Portuguese is not the best one now because I didn't practice for about 10 years. But we have several Brazilian here in the Rubin as astronomer or engineer, so I can ask for help. So this is one I think that I can do for Brazil, is doing a teaching workshop for Brazilian teachers in Portuguese. But in any case, we also have in Spanish workshop. We also have a lot of collaboration with the other EPO team in Chile, of other telescope, AWI and ALMA and ISO. So we are working all the EPO. We will try to work all the EPO team of observatory here together. So this is more or less what we are doing in Chile and what we want to do in the South America. Continue doing a lot of workshop for teacher. Formal education, Ardis will continue with that.
Okay, thank you, Fernanda. So can we go to the next? There we go. Our formal education program is entirely online. So what we have done is we've decided to develop investigations that can be used only by accessing a website. So there's no paper or materials or anything that you have to buy or get. We've designed our education investigations to work for students who are in late middle school, advanced middle school, through an introductory university level. So we don't assign a specific grade level for them, but we have 7 available right now. Stellar Safari is our newest one. It's actually going to go online within the next few days. So that's pretty exciting. But all of these investigations are designed to be completed in less than 2 hours. And all you need to do to do the investigations is to access a website. All of our materials are classroom ready. You don't have to buy anything. You don't have to install special software, even though all of them use authentic data. You don't have to download them. So everything is done kind of in a cloud-based format. And as I mentioned, our investigations are designed to be done in a few hours because we understand the constraints of the classroom. And we know that teachers don't have a lot of time to teach all of these different ideas Right now, as Fernanda said, our investigations are in English and Spanish, and I think at least one of them in French. Something we discovered is that what you can do if you're using a browser like Safari or Chrome is you can translate the investigations into many different languages. And if you did it, for instance, in Portuguese, it wouldn't be perfect, but it would be, most of it would be there in an understandable way. So that's another way that you can kind of get around the issue that we don't have all the material right now available in Portuguese necessarily. Everything we do is totally free. Everything's under Creative Commons license. So you can download our materials, our support materials for this, and use them and modify them as you'd like to. All of our investigations are designed with the tools to access and analyze data right inside of the investigations. And so what we've tried to do is we've tried to parallel a science process that professional astronomers would use without going through every single detail of how you would have to access and reduce data. And so we're paralleling the process, but we're making it accessible at a level for novice learners, people who are just brand new to astronomy. This is maybe their first experience of learning some astronomy, and they're going through this to just get like the very basic ideas of how we look at data and come up with some ideas of what that data might be telling us. We emphasize the nature of science. It's not set up to be electronic workbooks where we type in an answer and then you get, yes, you're right, or no, you're wrong. It's not like that. In the same way that if you do a science investigation, the universe doesn't tell you if you're right or wrong. So we've kind of followed along that same thing, made our investigations a little bit more open-ended. And we also, right now, even though our observatory is not producing data, are using data from other science surveys and telescopes and such. And if you have any questions about that, Clare is our data scientist. She can speak more about that. Okay. In addition to the online investigation, we have a lot of other materials that teachers can use. We have a warm-up activity for each one. We have 4 different kinds of assessments that teachers can use either during the investigation or afterwards to check for understanding. And we have other materials as well. And some of them right now, like our science videos, are only in English, but Fernanda is going to be working to get similar science videos translated for the Chilean audience at least. So we'll have them in Spanish eventually as well. Okay. One last thing I wanted to mention is that because we're very, very invested in wanting to make all of these investigations and activities accessible and inclusive for all, there is a part of our website called Rubin Voices where we do staff profiles or science profiles of people working on the telescope. And we call it Rubin Voices because in addition to having the regular profile you might see on other websites as well, we have video clips where you could hear the person's voice. So kind of bring in a little bit of a different aspect of diversity. If you go to the next slide, Fernanda, I will just mention, oh, we can do that too if you want. Okay, there is a education activity we've developed for Rubin Voices where students explore some of the different trading cards and for these scientists and other staff who are working at the observatory. And then they have to make their own trading card as if they were a Rubin Voices star and fill in their information. And our idea here is that we want students to get thinking about visualizing themselves in a STEM or STEAM career. And so this is just another optional activity that can be downloaded as part of the education program. Okay, and the last slide I'd like to talk about is that we have many different ways to support teachers. So we go around and do some in-person teacher workshops. We do virtual workshops like the one Fernanda is talking about that we're doing on Friday. We've been working with people all around the world on these virtual workshops. We have a professional development page, and on that professional development page, we have videos of many of our past workshops that people can watch if they'd like some more information about our training. And then finally, we have a community of practice so that teachers can join either on Facebook or on email and talk to each other or ask questions and get help for the education program. I will also say that one other thing is that there are real humans here behind the website. So when teachers need support, something's not working, we're here to help them as quickly as we can. And that's something I'm very, very proud of, that our observatory is committed to helping humans in as close to real time as we can, instead of just putting a website out there and having people struggle to figure it out on their own. This is the end of what I'm going to talk about. I'm going to be leaving our presentation, but I wanted to just ask Fernanda, would it be okay if anyone had questions right now about the education program?
Yes.
Questions? No questions for now.
Okay, thank you very much for your time today. And you could always email me if you have any questions that come up in the future.
Thank you, Ardis. So now we will continue. Oh, we have one more slide about the online outreach and content. We also have one slide that Miss Ardis, that we have a web page that you can see either in computer, or they are also can see in the mobile phone. So we have all these things is mobile friendly, and you can follow out also in our social media things. Oh, we have a gallery also, the visual gallery of photos. For now, we don't have any image because it's in construction, but we have a lot of image of our telescope. And we also have in the website a videos that you already see, another video that you can use also for the investigation that we have for education things. Oh, and also on our social media, we have several social media. You can follow up here, and we can see how many people are connected. We have a lot of people from Chile connected to social media, another country 32, and United States 25% of the connection of our social media. So now is Clare with Citizen Science. Go ahead, Clare.
Thank you. It's great to be able to talk to you all today. I'm going to give a little bit of a in-depth look at one of our EPO projects, which is our Citizen Science Initiative, which hopefully will be of interest to you all. Go to the next slide. I'm just going to start just a brief intro to citizen science in case you haven't been thinking about it. But it's essentially a way to draw volunteers from the global community into participating in the scientific process without needing a kind of scientific background. And so here's just a couple examples that aren't all astronomy. And just to highlight the fact that citizen science takes a couple of forms across the world, including having your volunteers participate in collecting the data. So there's this project that takes place in the US where there's little brackets, so you put your phone in national parks and you take a photo and you upload that photo and you look at how landscapes change. There's projects like iNaturalist, which is a global project looking at flora and fauna across the world. And there you have people contributing, classifying data. And here's another example from the Zooniverse, which is highlighting different regions, which is kind of something that doesn't really work very well without the human eye. And so you can have these participation. If you go to the next slide, I just mentioned the Zooniverse. The Zooniverse is one of our partners for our program. So just want to mention it in case you haven't encountered it. This is a very well-known global online citizen science platform, which has a really nice interface for both people creating the project and also volunteers participating in the project. And it establishes some modes to have kind of conversation and really productive discussions between groups. Next slide. On the Zooniverse, it's not just astronomy. There's a ton of projects from many different areas. And these are kind of interesting to look at for inspiration, because some of the techniques used in classifying writing samples or weather data, have interesting applications to how we might run some astronomy projects. Next slide. Of course, there's lots of citizen science astronomy, which are probably mostly interested in. Here are some of the projects that are currently on the Zooniverse based on astronomy. Most of these are the kind of classification type, where you're having volunteers classify your data and look for features or types and kind of group it that way. There are other astronomy citizen science projects. So I'll mention like the Unistellar project, which is following up on supernova and getting the public to take the data. That's not quite what our mode of citizen science here, but it's useful to mention. One of the reasons we're really excited about citizen science is it can be so beneficial to both the science community to do analysis and the public, because it's a chance to get up close and personal with the data and a chance to be part of some of the amazing discoveries that we'll make. Okay, next slide. So our Ardis has given a great example or overview of Rubin, but just remembering the fact that it is a survey telescope looking at the whole sky. And if you go to the next slide. We have this huge data set, which is looking at a huge number of research areas, which Ardis covered. And this just kind of emphasizes the fact that we need help and we need all the different methods as possible to make best use of this amazing data set. So on our next slide, citizen science has been in mind as a great resource and tool for astronomers trying to get the most out of Rubin, and also for public participation since the beginning. So here's kind of one of the LSST science papers emphasizing the fact that this is, we're going to increase dramatically the number of projects, and they create this amazing opportunity. And citizen science and Rubin are such a great combination because we have this huge amount of data that covers a wide variety of science cases. And I think most importantly, one of Rubin's intentions and goals is to discover the unknown, is to answer questions we haven't thought to ask yet, and find the unusual and the unexpected and frankly the weird things that are out there. And citizen science is a great place for doing that. And there's many examples from previous citizen science projects about finding these kind of odd, anomaly, unexpected things, like green peas in the SDSS galaxies, for example, or SDSS survey, for example. So citizen science really is for everybody. For our scientists and our science communities, this is such a great tool. For educators and facilitators, this is a great way to bring Rubin into different communities. And for the public, it's a chance to get to be involved in the process. So there's a little overview of kind of why we're thinking about citizen science. You can keep going, Fernanda. And so that's kind of the high level. And let's get into kind of how we're planning on doing this. So as I mentioned, we're partnering with the Zooniverse to present these projects. And our goal is to make an easy pathway for people to create projects and have them on the Zooniverse, and to meaningfully engage with the public to highlight the amazing science. So to be very clear, our team is not going to be running citizen science projects. I wish we could, but unfortunately we can't, simply because we're a small team. There's so many projects out there. But our goal is to kind of help members of the community, help both scientists based in the US, Chile, and across the globe create these projects for volunteers across the globe. And keep going, Fernanda. And so quite simply, there are kind of two main parts for our scientists. One is we've created a pipeline that goes from the Rubin Science Platform, which is where the data lives and where the data can be accessed, to the Zooniverse. This significantly reduces the kind of learning curve of how to do this, how to
We lost her?
I don't know if me or Claire.
I think we lost Claire.
Uh-oh.
Wait a
I
couple
will-
of
I
minutes.
I will ask.
Please ask questions in the Google Docs. You can send it here.
Ia perguntar how, mas ela vai responder how.
We can wait until 1 minute more to Claire. If no, I can continue with the presentation of her. I'm no expert in citizen science, but I can help with that.
We can wait a couple minutes.
Yes.
So there's a question about, there's a question from Augusto. Do you want to open up your microphone and ask Augusto?
Yes, but I think maybe it can be later because I think it's related to the outreach activities. So I don't know if we should wait for Claire to come back, maybe. I don't know.
If you want to talk about outreach activity, I can help you with that maybe.
Okay, yeah, I was just wondering, like, I heard recently that there is some kind of negationism propaganda that is trying to convince the lay public that the USA government spends too much in astronomy-related technologies. So I know as well that there are other kind of negationism propaganda related to astronomy. So I kind of wanted to know if there are some long-term strategies included in the outreach activities to deal with this kind of negationism propaganda.
Well, this is very focusing in United States activities and outreach. So sorry, I am no expert in this part about United States. Claire maybe help you with this question because I am working more in Chile team. So we are doing a lot of outreach with the community, at least around the telescope. What is main important for us is the dark pollutions. So the light pollution. So we are working a lot with the student and with the countries around us, around our telescope, just to help with that. But just focus in the United States, maybe we have asked to Claire that the team of TIS is more focused in United States outreach.
Thank you, Fernando. Maybe you can
Just
continue.
1 second, because Claire don't have the link now. Okay.
It's in Slack.
Yes. Yeah, okay. I sent her. She's connecting now.
Great.
Hello, can you hear me now?
Yes.
Yes.
I'm so sorry, my internet just dropped, so I had to switch to my phone. Where did you lose me?
In the goals and the pipeline, and we provide documentations.
Okay, great. So yeah, we provide our documentation and support from our team. And as Ardis was mentioning, you know, the education team has people behind it. This SitSci effort also has people behind it. So we're here to help and support any problems and things that might come up as people try and do these projects. Okay, next slide. So in a little bit more detail, we've basically created a software package and some Jupyter Notebook tutorials that demonstrate how to curate your data and send it via our pipeline to the Zooniverse. These are available on the Rubin Science platform. And we have tried to create examples which are good starting points for many projects. If you want to know the details of how this works, we have a recorded demo that's on rubinobservatory.org. Yeah, you can go to the next one. We are building tools and hopefully a community for our Rubin Observatory to help you make projects happen. And so we're doing this again to support our scientists to make building and running and maintaining a project easier. We're doing it to leverage our EPO mission and priorities that Ardis mentioned about reaching a broader audience and getting more people to participate in science. And also we're trying to help with the data volume challenges. One of the great things about Rubin is about how much data we're going to get, but that is also one of the challenges. And so we're trying to support people navigating that. Okay, next slide. And so, as I mentioned, we're hopefully providing this ease of use with our pipeline, support from our team, and we can also provide communication engagement strategies for our audiences. And so what we're hoping to find are people who are very excited to be a project lead and share Rubin with the public, who are ready to coordinate and collaborate with our Rubin community and beyond, and who are also have an interest in welcoming more people into doing science. Citizen science is a great place for many people to participate. And we're hoping to create a dedicated community of volunteers. We're going to need a lot of eyes on our massive amount of data. And so we're trying to create this Rubin family of projects. So we have a lot of volunteers who are happy to work on a project looking at, I don't know, solar system asteroids and then galaxies, and then looking at strong lenses. You know, have people who are very comfortable with Rubin and are participating across our science areas. And so we are connecting to our other EPO materials to broaden that audience. And also we do have some translation support that is available. This is a bit custom to the project and the project team and audiences that might be interested, but we do have some of those resources available that are kind of tailored to each. Okay, next slide. And as I mentioned, we want to connect to the other EPO initiatives, which you've mentioned throughout this talk. But one I'll kind of just highlight is, you know, connecting to our education program that Ardis went into detail. Citizen science can be a great resource to go beyond what those education investigations bring to the classroom, and those education investigations can be a great way to support learning through the citizen science initiatives. So, through the citizen science projects. So combining these initiatives makes a lot of sense, and we're really looking forward to it. Next slide. And just as a kind of visual demonstration, on the left is a map that shows kind of some of the current Zooniverse volunteers, and on the right shows educators who have participated in workshops for those education investigations. And so one area that I'm particularly interested in, South America has a lot less volunteers than educators. And I would love to you know, change the map on the left to have a bit more of a global audience, and connecting with that education program is a great way of doing so. And it's also one of the reasons I'm very excited to talk to you all today. On the next slide. So if you have thoughts as I've been going through this, and if you're somebody who may want to run a project in the future, I would suggest checking out our website, which I've listed here. There we also have an interest form, or you can reach out to me with any questions or thoughts or considerations. We're still building and developing this initiative, and we really welcome your input, particularly if there's ways we can make it more applicable and useful to your work and your research and your intentions for this. Next slide. If you're somebody who just might want to volunteer in projects, we have a website there, or if you know people who might want to be a future volunteer, you can check out our website, our social media, and we're also hoping to start a talk series about the science to come with the citizen science program. On the final slide. If you're just somebody who's excited about this program and you're not quite sure where it fits into your research or your thoughts, I would just encourage you to keep an eye on our website, and definitely if there's a way we can make this more applicable to you or more exciting to you or something that you'd be more interested in, I would love to hear me. So we have that email there, and I think my email is on the title slide of this talk as well. And you can reach out either way. So yeah, there's a lot of things there. So I will stop there and hand it back to you, Fernanda.
Yes, thank you, Claire. If you have any question, I think we have a question from online question that I don't know the answer. Maybe you know about the answer. If Alacen, I don't know if the name, can I again do the question? Will be perfect. Maybe Claire can answer the question.
Yeah, sure. Thank you for your talk so far. I was just wondering if I know that there are some kind of a negationism propaganda spread in the USA specifically, but I worry about that because usually this negationism propaganda it spreads to other South America countries. So it is a kind of propaganda that tries to convince the lay public that the USA government spends too much in astronomy-related technologies. So I wanted to know if there are some long-term strategies included in the outreach activities to deal with this and other kind of negationism propaganda.
That's a great question and a big question. So I think there's a couple things that we do. Is one, we really try and keep our program is hopefully connecting the public to our science and the data, and hopefully creating a more direct connection, and so people can see things and experience things by themselves, which I think helps though that doesn't necessarily reach all people. Our initiative to try and expand the people we connect with, we are trying to connect with people where they exist. So we have a large social media presence, mostly because a lot of people are on social media, and some of the people we connect with there are not people who typically are seeking out this content. And then we have the opportunity to present our narrative and our the message we would like to present about the importance of Rubin and why it's such an amazing addition to our understanding of the night sky. And I think also on a final note is through things like the education program, we hope to kind of develop the understanding of critical thinking and reasoning and kind of understanding how you draw conclusions from data, which I think are skills that are really fundamental to changing some of those perceptions. So hopefully that answers your question. But yeah, it's definitely a multifaceted thing.
Thank you very much, Claire.
Thank you, Claire.
Hi, thanks for your talk. I wonder how are these citizen programs work if it is the scientist or the person who proposes, or you guys propose the program and you invite people to collaborate, how it works?
Sorry, are you asking how we find project leads or project volunteers?
I'm asking how the project is idealized. Is a person that wants a project to be developed at the observatory, you propose a project, the person, the citizen propose a project, or the observatory proposes a project and then we can join, for example.
Okay, yes, I understand now. So what we need is a scientist or scientists, a group from our science community to propose a project in a science area. So there are some projects which we know we have people that are interested in running, and then we will help them bring that to the public. But it is an initiative that has to be led by scientists in our community. And that's for kind of a couple reasons. One is the fact that, hopefully these projects will produce discoveries and papers and that kind of research. And that really needs to be carried by a research group. One of the things that we are doing on our team is trying to connect groups that are trying to do the same research. So if you have two projects who want to study, I don't know, galaxy morphology or something like that, we can create connections within the science community saying this project is happening and these people would also like to do this project and kind of create those collaborations if they make sense and work for everybody involved. But it is driven by the science community primarily.
Okay, thank you.
So Thaisa is thinking of a project in the near future.
Everybody can do project.
Okay, so we have a few questions here in the Google Doc. Would you like to ask yourselves?
I made my question, it was the third.
Okay, the first one, if not, I'll ask. What are the documented impacts of citizen science on the life of the public that participates on it? Hard one.
That's a good question. So there's some there are some studies. There are definitely some examples of citizen scientists being co-authors on papers, going on, particularly if they're junior or perhaps high school students, going on to a career in astronomy. There is a citizen scientist who I know who was LSST time to follow up. So, there are people who go from a kind of non-science background, but with support of a project, end up kind of participating that way. But there's a lot of anecdotal evidence of people really wanting to participate and really wanting to be involved, and it bringing a lot of meaning. And there's been some studies about the motivations of why people do projects. And one of the primary motivations is people just like to do science, and they want to talk to scientists, and they want to be part of the process. And the Zooniverse has, I think it's almost 3 million volunteers. And it's got over 800 billion classifications, which I think is kind of evidence of the fact that the public wants to be there and wants to participate. But the lasting impacts on the public can vary between someone just having fun and, again, someone being involved, on a paper and things like that. And that is dependent on the research group, and that is a space where we hope to kind of support and encourage our PIs to have more meaningful impacts. But it kind of gets custom to kind of the project type in a way.
The second question here is, what is the profile of the people who participate now in citizen science projects? Is there any demographics that you aim to achieve besides what you already showed about South America not being?
Yeah, so South America is definitely one of the easy ones there to emphasize. There is a kind of there is a kind of skew toward older folk, and we would like to make sure we encourage younger participants. That is not to say there aren't younger participants, but so that's kind of one of the things we'd like to do. But again, just in line with the EPO's general mission of kind of bringing this to people who wouldn't necessarily traditionally participate in these projects, and it's just kind of expanding the audience. So we'd like to reach more younger people and an international audience. Well, of course, we have to focus mostly on the US and Chile as our primary ones, but citizen science is an opportunity to be truly global, and so we're looking forward to that.
Great. Are there more questions from the audience or Zoom? So I have one. So for the people that are not do not have data rights, does it matter for them to want to lead a project in the EPO program in citizen science, for instance? How does that work?
So yes, but it's not impossible. So there is data that is globally public right away. So data based on our alert stream coming out of the alert brokers is globally public. So if there is a project that is reliant entirely on that data, we can support it. The pipeline that we have developed relies on using the Rubin Science Platform, and to access the Rubin Science Platform, you do need data rights. However, this is a moment also where we can kind of encourage collaboration. And so if you are somebody without data rights, but a good project idea, there's potential to connect with other groups who have a similar interest, who perhaps do and can support that way as well. And I will say, Ardis, I think, mentioned earlier the fact that, after 2 years of the proprietary period, the data is public in world public, and then it's open in that way as well. So
I had one more question. I should have taken notes, but I forgot. Well, leave it for, I'll write later on. Are there
Perfect.
more questions? If not, let's thank Claire and Herrold.
Thank you, Anna.
I remember the question. What are, do you know the level of the education